Next, we introduce the 3 SLAM features of GeoScan S1. Please note that before any SLAM program is initiated, please make sure that our equipment is on level ground in order to perform an initialization, and you need to pick up the device to build the map within 2 seconds after the program starts. Avoid point cloud buildups that can lead to program blocking and jamming. If this happens, you can restart the program. Double-click on the icon that launches Quick Build. A selection dialog box will pop up on the desktop. Stabilized building maps for highly dynamic scenes, and the 2 modes of map building provided by the odometer stabilization. The first high dynamic stabilization builds the map. Clicking on it puts us in the scene. Quickly build colorless point cloud 3D maps, and save the constructed point cloud map to the PCD_result folder on the desktop. The second odometer is offered steadily. This mode should be used for highly dynamic environments. Examples include devices mounted on high-speed unmanned vehicles, quadruped robots, humanoid robots. In a highly dynamic environment, a stable odometer needs to be provided to ensure that RSLAM's odometer and the robot's space position, no drift or misfit in the space environment. The main purpose of this map building model is to provide a stable odometry for users who have a need to develop functionality. Generally, the first high dynamic stabilization mode is chosen. During this process, we can also click to start recording data. The data used is then recorded in the background. As you can see, this is the current environment. On the screen, you can see that the entire room can be constructed in 3 dimensions in a very short period of time. Save our point cloud results with a single click on the saved file. Click on it and a dialog box will pop up on the desktop. It first stops the data recording process and detects if there is a corresponding point cloud file. After detecting the corresponding point cloud file, we will be prompted to save our file to the desktop and save it with a timestamp as the name. Please be patient for a few seconds after clicking OK to finish. It automatically cleans up the desktop terminals. Next, you can go to the PCD_result folder on your desk to view the constructed 3D point cloud file. This file is the constructed 3D point cloud file saved in PCD format by default. We've done a good job of adapting the double-click, just double-click to open and view the point cloud PCD file directly. As you can see, since it just moved a very small area, so it only builds a corner of the room. Later, you can also pick up and move a larger area to complete the construction of a larger point cloud map. We can also see that a file called databag is also formed under the folder. This records our scanned data files. In order to prevent packet loss during data recording, a bag file will be recorded every minute or so by default. Since the recording was relatively short, there is only one data0 bag file now. If the recording is longer, there will also be data1. Data to all the way up to the data.m.bag file. It's based on the time we recorded. This ensures that we do not fail to collect data due to force majeure or other human interference during the data collection process. As long as there is this bag file, later using the data playback function can be our entire data acquisition process and the results of the graph to reproduce it. Next, let's take a look at the second odometer stabilization that provides chart building functionality. This feature is primarily used for posting file odometers. Startup options wait a few seconds for the program to start. At this point, I picked up the device and shook it violently. As you can see, my shaking is very violent. In this case, clicking save will still save the results. The saved program will still go out of the background to grab if there is point cloud data, and save the point cloud data to the desktop folder. Wait a few seconds for the terminal to close automatically. In the PCD_result folder on the desktop, we can see the point cloud file that we just built with the second quick build mode. Since our move is relatively short, so it builds a point cloud file with only point cloud density and clustered in only one corner of the room. If we want to build the whole layer, we just need to start the program in the. When you see a point cloud appear in the point cloud construction screen, slowly pick up the handheld scanner and move across the room. Then return to the starting point. The dense building function is different from the fast building function, mainly for some interior areas that need to be focused on, architectural structures, forestry structures, and special sculptures, as well as steel structures, among other areas. It features fast construction of colorless dense point cloud maps. Double-click to start the program and wait for the device to initialize. You need to wait 6 to 10 seconds for the thick map building function to start successfully. After the 2 axes appear on the screen, within 2 seconds of picking up the device and scanning it, you can see that our entire scene is very completely constructed. The point cloud density is very high. After putting it back in place and clicking Save Program. The save will grab the processing point cloud file from the background and save the result to the desktop. Wait a moment, and the terminal will close automatically. Open the PCD_result folder on the desktop. You can see the new PCD file we just added. Double-click to open to see the point cloud file just collected by Quick Instruction. The entire room was captured in great detail. Double-clicking on the color build icon will bring up the first selection dialog box. Selecting the camera's exposure mode. Because GeoSkin S1 fuses IMU, LiDAR, and wide-angle camera data for point cloud color assignment and real-time color rendering. You need to first select the mode of the camera. In the introductory section of the Startup Camera, we recommend that you use the camera functions to determine the most appropriate camera parameters for your current environment. The most suitable camera parameters we've just determined are the high exposure parameters. So at this point, we also choose the same high exposure. Select the mode of operation for SLAM in the second selection dialog box that pops up. 3 modes: indoor, outdoor, and regular. The indoor mode is generally used in closed interiors or in environments such as underground garages, tube corridors, and closed tunnels. Conventional mode is generally used for tunnels with long distances, or use it in some environments that is semi-open and semi-sheltered. Outdoor mode is generally used for scenes with fewer feature points or some cases of large scenes. The 2 modes we usually use the most are indoor and regular. Outdoor mode is relatively rarely used. It is recommended that you choose on a case-by-case basis. Now that we're indoors, choose to activate indoor mode. Click OK and wait for the device to initialize. It takes 6 to 10 seconds to initialize the device, and then pick up the device. You can see that the color of the whole room is completely restored. Since I'm in an environment where the rest of this corner is dark with the lights on, you can see that the entire color is being reproduced realistically. Click Save and wait for the program to grab the data and save it to the PCD_result folder on your desktop. If you need to export the scanned data, you can also copy it out through the USB 3.0 port on the right side of our device via USB flash drive. Now we can look at the results of the scan we just did. Since the scanning environment only has one light on in this corner, the black area around it is colorless. Areas with colors are normal scan. You can clearly see the basic conditions of the scanning environment.